Okay, so my introduction won't be in the recording, but whatever. So as I said in the first slide, I will move back to this one. Today, we are talking about configurations and design intent. I will just talk briefly about design intent. What is it, design intent, and why do we need it? Design intent is the way you make your models to be stable, adaptable, and to fulfill the requirements that were placed at the beginning of the project. To achieve this, student George, can you mute yourself? Thank you. To achieve this, first phase of the design intent is the definition, or when more is less. In the past years, there are a lot of, I would say, gurus of SolidWorks that are trying to explain how it is good to have as little as possible features in your feature tree. And while this was partially correct, it led to a trend which is not good at all. People started skipping things which are important. And these are guiding sketch, reference geometries, and sketch pictures. When you skip these parts in your feature tree, this is going to lead to a model which is unstable. And what unstable model means? This means when you are making a change somewhere in the model and then half of the features are getting broken. I'm pretty sure everybody has experienced this. Me too. It's nothing bad. It's the way we learn how not to do the things. So I would ask, now I will use approach from our champions meeting. So if you had this trouble, please share +1 in the chat. Nobody wants to share. Okay, so when we're talking for definitions, then we have the basic ones, as I said, the sketch picture, the guide sketch, reference geometry. And then we have the advanced ones, which are custom properties, configuration tables, design tables, global variables, and equations. So, and today we will pay more attention to global variables and configurations. Not with configuration table, just the pure configurations. Why? Why we're doing all of this? Because if you have a model which is correctly structured with the correct configurations, you can achieve what is in this design structure example. These are absolutely real numbers, which I took from one of my designs. The model has 63 features, 24 configurations, and it has a total rebuild time 1.2 seconds. Because everything is done with design intent. And what you see on the right side is actually a screenshot from this particular model with this structure example. And now we will go to SolidWorks, where I have a model. This model is built with design intent. It has different stages. As I said, the first is the define stage. I do have a sketch picture. So in reality, I imported the drawing inside of my model. This way, for me, it's easier to build it. So somebody's unmute. Can you please mute your microphones?
Yes, I give it to you. It work.
Okay, so I would just ask once again, can you please mute your microphones? Or yes, if you can mute them, please, because it's a bit distracting, all these noises. Okay, thank you. Then I have a guide sketch on the top, fully defined sketch based on my picture. And you can see the sizes here. They're corresponding if you can have a look everywhere. Then I have the second guide sketch, which is from the side. I will hide the sketch picture. And based on this, I start building my model. And when you're building with design intent, you should first add material, then remove material, and then as last step, add the finishes. This practice you use to avoid errors. Because if you model these holes first, and then model the next one, and actually I will just do this. You see what happens if I don't add this cutout afterwards, or make the cutout first and then continue modeling. In this case, the cutouts are coming afterwards, so they will fix it. But still, this should be done on later stage. And now when we are ready with a model, which is done with design intent, we will move to configurations. What we can do on this stage. First, we have this part, which is with these sizes. And we have, for example, a family of parts, which are similar to this one. We go in part number 1, go to the top, guide sketch, and say, for example, for part number 1, this size, you should go here and click only in this configuration, will be 60. And we have the part which is 60. Then we go to the next one, and as you can see, it's returning to its original state. Here I will go in the other configuration, and here I will change the size to 40. And I have the part like this. So we have first part, which is 30 and shorter, the second, which is the longer one, but higher. And then I will go in this one. And I will change the angle to 60 degrees. And I will change this length to 75. I do have actually an error now. Ah, yes. Okay, the problem here is that my whole cut now is going inside the model. This means I have to change also this length here. Excuse me. So it was a bit wrong definition from my side. Now it's correct. Okay. And now we have a family of parts just with changing few numbers in our model. But we can do it even easier instead of going inside into different sketches, and we can use a global variable. We go on insert, no, on tools, sorry, then open equations. And you will see this screen, and you will see this here, global variables. So first I will make L with a value of 75. I think it's in this case. And as a comment, I will add a length of the arm. Then I will add another one, which is H.
After some time.
And this will be 30. And this will be height of the model. Then I will add another one, which is LH. It's also 30 at the moment, and that's the length of the cut. And I will add A, 70 degrees, and go of the arm. Okay. Now I will go inside the sketch and will exchange the values here with the global variables. This one we said is L. This one is LH. This one is the A. And the last one will be in the other guide sketch. This one is the H. Now, because I first made the different configurations and afterwards I create the global variables, now I have to change them again with a different value for the different configurations I have. Like going here, now you will have already the equations on the tree, and you can right click and go to manage equations. And now we can change the value for this configuration to be 65, for example. H for this configuration will be 35. This will be also 35. And the angle will be 19. You can check the mark here, so it's automatically rebuilding, and once you hit OK, you will see the part with your new values. Here is the model in 3, and then we have the model in 1, and we have to make a different one for 2. Oh, for 2 is still with the correct values, it seems. That's nice. Now it's the old ones. Okay. And the other option is to show this configuration table, in which you can also change the different values. The problem is in the configuration table itself, you see just the values, not to what they're corresponding. Okay, the degrees are more or less clear, but the rest is not very well, so better use the equations instead.
The guy started lecturing.
So, do you have any questions?
No questions yet.
Okay. Then I will show you one more thing, which is a bit more advanced. In this case, I will go inside this sketch. The thing is, here we do have a cutout, and sometimes it's better if we can restrict this going inside the cutout. Or the other option is
You used to know what happened to you.
to make the cutout calculated.
No, that not verify.
So I will go to equations again, and we'll add a new global variable. But this one now will be calculated. For this, we will use a function called if, and it will be if the height is bigger than 30, then the value will be 15. And if the height is more than 40, then it will be 20, and else if will be 10. So let's see if yes, I was expecting this. Sometimes it's really hard to guess designators here. Hmm. Okay. I will check the syntax of the function here. Mhm. Oh, make it a different way. Oh, I know what I did. Okay, now it should be correct. We'll make it 31. So I put one too much. So if the height is more than 31, it will be 20. If it's less, it will be 15. Now I will go to our site guide sketch. And I will say that this one is equal to our new calculated global variable. And now it's 15. And as you can see, if I change now this to 35, it's becoming 20. These calculations, they're a bit more complicated, but they're extremely useful in constructions. Because there you can make it calculate where to put additional support or such things. Actually, you can see this also. I have a video in my channel and I will just share a link in the description. These two videos, they are showing exactly this, how to use equations and also global variables to make your models better. Okay, and now adding data in configuration tables. Yes, okay, then I will make your configuration table. Not this one, so insert tables. It's actually design table. When you make it automatically, then you will see most of the things inside. And this is the fast way to make more and more configurations. Because now, I'm sorry, now, for example, I can take this one and just go on. Okay, it didn't work as expected. Add new configurations. This can be the same for the rest. And let's see what we have here. And that's our problem. Okay, first I will fix this. Now we see that these are the global variables, or you can use it as a configuration. Now 2 is different. Yes. And now it's warning you that your configuration will be changed in the design table too. You can make the design table also, double click, edit table. When you put it inside, you can make also the design table to block different values. And you can see here that you have actually the global variable value and its description. And now we made the configurations to be corresponding. Now I will go again and add 4 more. And here too. And all this I will repeat. And what we have to do here is only change. Let's make it a bit more tricky values. The length of the arm will be 60. Then we will have 62. 68. And 72. I will leave the same height of the model and the same length of the cut, but I would like the angle to be for 90 degrees. So I would just copy and paste from the other cells. And once we hit OK here, it will say that design table has generated the following configurations: 4, 5, 6, 7. And if we go and look in these configurations, they're corresponding to the values that we have given, which is just the length of the arm in this case that was varying. So, any questions? Of course, you can change the value also here if you're not using design table. But as I said, that's really not a very convenient way because you do have the 3 dimensions, but you don't know actually what you're changing. And in this case, it didn't work. And do you know why it didn't work? It didn't work because we do have the value of the dimension in the sketch. And we changed that to be driven by equation. So it's driven by equation value. And that's why actually it didn't change it. But see, it's even shown in purple because it's driven from our design table too. Well, that's all actually. And now it's time for questions if you have any. If you want me to repeat something, to show you something more about the design table, about the equations, now it's the time to say it in the chat. Okay. Yes? Would you like to join me now? Okay, so we do have questions. I will start with the first one. Can color also be included in the table? Normally, yes, but it's not these colors that are on the top of the model. So I'm not quite sure how exactly this one can be used. If I go in edit table, actually the first here is the color. But this color is represented with numbers. And let's see what will happen if I change the 5th configuration. I doubt it will change because what I placed are colors on top of the model. And maybe if I remove the appearance, it may work. But I doubt. So really, I have no idea what is this color inside. And okay, now our colors has changed. Nope, Not what it is. I mean, I have no idea what they're representing. And with these numbers, it's really complicated to predict what the result will be. If you would like to play with that and to try it out, you can do that, of course, but not in the way you expect. And I assume this to happen. Actually, you should go first here in properties and link the display state to the configuration. This is what I use when I want to have different colors. If it's not checked, this means anytime you change it in a different model, it will be a different. Can we use design tables and configurations for bigger models? Of course. The idea is to use it for bigger models. I have had also design tables which are not really, you should scroll a lot to go from one to the other side. Because as you can see, everything you control here is individual column. So I have had to the double letter ones and here on the other direction also. But when you want to control bigger, much bigger things, I would advise you not to look on the design table like this in the screen, but to use the other approach, which is edit table in new window. And then it will open Excel. And here it's much easier to work with the bigger tables and the bigger assemblies. Yes, I suppose the number are color codes, but as you can see, it didn't work out. And I don't know which color codes are these numbers. That's to the correction that the number are color codes. Maybe now when I link the display states, it will be different. Yes, we do have here 6 is different, which is the blue one. And now it should go to 2. Yes, it went to 2, but the thing is, you should make it first because now you have this number code. And I don't know for you, but be my guest to guess what this means as a color. Because in this case, this means a blue model with red edges. So you have to build it first to see the code. Then you can transfer it. But first you have to do it. Okay, so Sun is asking for clarification on model scaling concept in reference to the design intent and design tables. So Sun, can you please clarify a little bit? So I assume you're doing models which need to be scaled at some point for some other use. So probably you're working with the big models. Is that correct? Okay, good, great. Then you can do this. In this case, we have different models. I will add a new configuration under this one, derivative configuration, and I will call it 1.1. I would advise in design intent and the use you have to add the scaling at the end. You go to the features and I'm looking for the scale. You scale the whole model with we have a new feature at the end, which is scale. And at this point, it's available only in the one. I will go again to the design table and I will edit it in a new window this time. As you can see now, it's telling me we do have a new configuration and we have few parameters which we can include. Now, here is our latest configuration, which is 1.1. I will copy then 2. And we'll make it to 2. Because this is the one which has parent, we should copy it. Here the parent will be 2. We should have actually a drop-down menu, which is not always working. So I will just type 2. Oops. And that's really annoying. It's a small bug of SolidWorks. Which is not allowing me to take the parent like this. Okay, it's a workaround. And this is our new, which is the scale and its state, which is suppressed. Oh, and here we will just have to pick the unsuppressed one. Save. And when I close the table, it will say I have a new configuration. And here we have a 1 of the second, which is with the same scale. But if you would like to have different scales in different configurations, then better first make 2 different scales into configurations. Okay, it didn't give me the value to include. I will start just edit table again. And sometimes this is happening. Maybe it would have been better if I have done it from the beginning. But yeah, at some point it will give you also the value to include here for the scale because it's different in the different configurations, or maybe not. Even if it's not working, you can do it later manually just to fix the scale. But as I said, more or less, you're copying the configurations that you want. Let's see if this will work. No. Then we make it like this. And this is also a fast way to create your different configuration with scaled model. It will be 0.5 in this case, but you should go manually through each if you want to change it. It's very important to change the scale. For particular configuration, you should mark that this is only for this configuration. And if you want it to be the same for all the configurations, then you can just mark it to be for all and change it. So is this answering your question, Sam?
Yes.
Okay. Any other questions? Okay. How to surprise from the table. I go to the edit table. And here you have the state. When you have state something, this means this is the state of the feature. And when it's S, it's suppressed. Even if you click, you will see the different options. Yes, is it possible to use this approach for the entire model as well? The thing is, what you will receive from the design table as an option to add to the design table itself will be something which is not same in all of them. I think there was an option to add. Yes. So if you double click on a feature, you can add it. And I will just take, let's say, fillet. And then the other. And in this case, I can say, okay, I will suppress the fillets in, where are we? In configuration 6, for example. And 3. And in 4, I will suppress the first boss extrude, which should actually suppress everything. And let's see what will happen. I don't have, unfortunately, any document or which I can share for configurations. But what you have to look for is a SolidWorks design table. I do believe there are a lot of video tutorials already. Now, as you can see, I'm entering the second model and it's without fillets. Because we did this in the table, we suppressed them there. I don't remember in which one. Oh, okay. Here, I think it was the first. Some of the... Okay, this is the other feature which we had suppressed. And yeah. But if you don't mind, I will enter the table again and will correct my color. Now you see we have different states that we have added, and it's already asking me if I would like to add also the parameters. And I can just say, okay. And literally everything from my model now is in the design table. As I said, I will correct the color because this blue is a bit annoying. once you click somewhere outside of the table, because like in this case, it was covering the OK button, it will just accept the click away from the table as OK. Now we can see the changes we already implemented in the design table. Design table is really powerful. It can control your model completely. So any other questions? What is BOQ? Do you mean BOM, Bill of Materials? Okay, yeah, okay, mistype. Yes, you can. In this case, when you have configurations, because when you're generating something with the design table, you're actually creating different configurations. You can include every single model, every single one in your model. I will just make assembly and we'll add few different ones to show you how you have to code the bill of materials to show the different configuration as a separate entry. One. So now I will insert a bill of materials, a standard one. As you can see, every single model has its own entry. The problem in this case is that the part number is the same because it was not defined correctly here. And if I go now in first configuration and I say that I would like to have user specified number, this will be I should go now again in the design table. And it's not added this information. Okay, so it seems I have to save and update. But as you can see now, I change. So the part number is different for configuration 1. You can control this also from the design table to have different configuration, part number. So in this case, configuration 1 and different description. And how you control this is this area here, part configuration grouping, display as one item number. You choose the configurations. Or display configurations with the same name as one item. If you choose this middle one, it will just show one. No matter that they're different, you don't want that. So either you display configuration of the same part as separate items, or you display configuration with the same name as one item. Both will work. And when you make a copy of this one, you will have increased quantity of this particular model. So, any other questions? Okay, configurations of the assemblies, they're exactly the same way. They're similar of the configurations in the part. What I use them for is, okay, I will just what one. Let's, for example, we have a bottle. Okay, I have a bottle here. This bottle has actually two parts, the top and the bottom part. We have 10 different bottles. This means two parts which are driven by different configurations. You can both control what's inside your configuration of the assembly and also what is the configuration of this one. So let's say that in this particular, I would like to have only these three. My bill of material have to adapt. So you have to choose also the correct configuration for the bill of materials when you're working with this. Now, I do have states, so configuration 7, 5, and 1, and only these three models in this one. Then I go to the default, and there I have 7, 3. Even I can change this not to be 7. Okay, it can be 2, 2, 3, 1, and again the 3, 7, but I have all the parts. I can have additional configuration, which is like with 4 models, for example. And again, here I can control which configuration of the part will be in this one. Yeah, so more or less that's the way. And something else, in configurations in assembly, you also control the mates. So you can have different mates for the different configurations. For example, in this one, this is concentric to this. I will add another configuration, which is 3. And I will suppress this mate, and I will make this concentric to this one. No, so I don't want to save the assembly. So going back, this one is concentric here, and going here, it's concentric here. There are many, many things you can do with configurations in assemblies. And any other questions? And by the way, because it's in there not any more questions, I will go back to the chat again and share these 2 links of the YouTube videos. There, the videos I'm showing the work with equations and configurations. This is exactly in assemblies. I think you can learn a lot from these 2 videos. They're using, as I said, both equations and configuration. What you missed, Sam? At the beginning, I was mostly talking about myself and basic design intent, but usually the modeling with design intent as an overview is a presentation which I was doing by its own. not in combination with configurations and equations, which is what was requested for this meeting today. And I like doing that because this is going in details in one part of the design intent. Okay, I will stop sharing my screen. Thank you too, Sam, for being so active. Any other questions maybe? Okay, it seems there are no more questions. Then, well, I would say that thank you, Uganda user group, for hosting me. And I hope this presentation was useful to you and you were able to learn something. Of course, there are still additional work you should do on your end if you want to deep dive into details about equations and configurations, but these are both advanced techniques and they, I mean, I maybe can talk just for configuration all hour, but this will block your head. So better to explore it when you're calm and see where you can go by yourself. A really powerful tool in SolidWorks and really good to use, especially when you have family of parts. It's saving a lot of errors as minimum.
Thanks for your guidance, Madam. We really appreciate.
Thank you, Sam. So that was all from me. We hit a little bit more than an hour.
It is fine. Plus or minus in science.
Now I see you, Sam.
I don't know if Derek is on the call, but before Derek joins, I want to thank you so much for sparing your time to come and talk to us, Uganda team. We are very happy for you. We've been seeing your chats with other user groups all over the world, and it's a pleasure that today you're presenting to us, Uganda. We have very many members preparing for their CSWP, and this configuration aspect is going to be a powerful tool for them. And before this year ends, if we call you again, we shall be giving you results that we have members who have attained CSWP, So yeah. We are very grateful and thankful. We profoundly thank you for especially sparing the time to give this free service to us. In Uganda, it's hard to get people with such specialty. So thank you so much, and we wish you all the best.
Thank you too. And yeah, I wish you also all the best. And global variables is something you can use always, even before CSWP. And actually, it's helping a lot to take this